Yeah. Hello everyone, welcome to my channel. Today we will discuss the question trapping rainwater. So let's read the question. The question is given that given n non-negative integer representing the elevation map, where the width of each bar is one, compute how much water it can trap after raining. So it is saying that you are given a array nums, which is representing the height of the bars, and width of each bar is one. Okay, so these are bars which is having width equal to 1. Okay, and this is representing the height of the bar. You can see it is 0, 1, again 0, 0, 2. Okay, so it is given the height of the bar, and you have to calculate how much water it can trap between the bars. You can see that it is the water which is trapped between these two bars. Okay, here also it is trapped between these two bars, and here also. So you have to calculate how much water it can trap. So as you know, width is one. Okay, so here it is trapped. Here it is trapped 1 unit of water. Okay, for this bar it is trapped 1 unit, and for this 2 unit, and for this 1 unit, and uh, and for this also 1 unit. So which is sum to 1, 2, 2 plus 4. Sorry, 2 plus 2, 4, 5, and plus 1, 6, which is our answer. Okay, so let's discuss the logic. So, seeing this question, one of the basic thing that comes to our mind is the brute force approach. Okay, so what will be the brute force approach? Brute force approach will be simple. If I am standing, suppose if I am standing at this, so how much water it can store depends on the bar left left of this bar and right of this bar. Okay, consider this bar. There is no bar. There is one bar which is higher than this, but on the right. Okay, but on the left there is no bar. If we try to put some water on this, it will flow. It will flow. Okay, because no bar is there to trap the water. Okay, although there is a bar higher than this on the right side, but on the left there is no bar, so water will flow from the left. Okay, so what we can observe that the amount of water stored above any bar depends on the height of the bar to its left and height of the bar to its right. Okay, if we consider this bar, so we can see on the left there is one bar which is higher than this, and another bar on the right which is higher than this, so which is preventing the water to flow, so it can store some water. Okay, so what amount of water it can store depends on the minimum height on the left and right. Means if we see there is a bar which is higher than this, and there is a bar on the left which is higher than this, so that only it is able to trap the water. So you can see among this and this is the minimum, and this is the only height which this bar can store. It can't store the height of this, because on the left there is no bar, the water will flow. So what we can see that uh yeah, what we can see that key water stored on this uh depends on the height of bar on the left and right. So what we need to do, if I want to know what amount of water is stored on above this bar, then we need to find the maximum height of bar on the right and maximum height of bar on the left. So in the left, maximum I can find this. Let me clean my screen so for better explanation. Yeah. So considering this bar, we can see that key on the left, this is the maximum height bar. And for this, on the right, this is the maximum bar height. And we have to take minimum of these two. Why minimum? Because if we take maximum, there on the left, there will be no bar to prevent the water, to trap the water. So it will flow. So we will take the minimum because that much water only we can trap. So this is the minimum. And what we will do, we got the minimum out of left means first we will find the max on the right, max on the left. And among these two, I will take the minimum. So this is the minimum. And simply what we will do, uh, we will uh, we will subtract our bar height with the minimum one. So this is the minimum, and if we subtract this height, we will get this one. Okay, so this is the bar, and we subtracted this, we got this water. So for each cell, we will do the same, or for each bar, sorry, for each bar, we will do the same. We will stand at the bar and we will check, we will run a for loop to check which is the maximum bar. So on the right, we got this maximum bar, and on the left, there is no bar. So we can't store water here. Now coming to this, again, we will check on the right, which is the maximum. I got this. And on the left, we got 0. So if we took minimum this one and this, so minimum will be 0. So we can't store water as the minimum height is lesser than our current height, so no water can be stored. Now coming to this, we can see that on the right we have maximum height of this bar, and on the left we have this bar with the maximum height. So out of these two, we will take the minimum, which is this. Okay, so height is 1 and my current height is 0. So it is greater than my current height. So I can calculate what amount of water is stored here. We will simply subtract height of this bar from the minimum. Minimum is 1 and minimum is 1 and current height is 0. So water stored is 1. Water stored is 1. Okay. So in this way, we will calculate for this, for this, for this, and for this. Means for all the bars we will calculate. So in this way, we will get our result. But the time complexity for this solution will be n square. Why n square? Because one loop I'm running for the bars. Okay. And inside that loop, I'm running another loop to find the height, which is maximum on the left, and find the height which is maximum on the right. So we are running a loop inside loop, which will result in the time complexity of n square. So obviously interviewer will not be happy. So let's discuss the optimized approach. What will be the optimized approach? So another approach is a two-pointer approach. So in two-pointer approach, what we will do, we will have one pointer on left. Okay, so that will be left pointer, and another pointer R, and two more variables will be required to store the left max and right max. So let's take it as L max for left max and R max. And I will initialize both as 0. Okay. So what I will do, I will check whether my left max is lesser than right max. Uh-huh. Before that, I will run a loop. That loop will run till left is lesser than R. These two pointers are there. If we move the pointers, I will move till they don't cross each other. So the condition will be left lesser than R. So, so I will check whether my left max, L max, is lesser than R max. Okay, lesser than equal to. So if it is lesser than equal to my left max, so what I will do, I will have my result variable. Okay, result variable with stored initialized with 0. So if left max is lesser than my right max, then uh, I will I will add to my result. What I will add? I will add left max minus current height. Current height, which is yeah, current height of L. Okay, that is the left pointer. So why am I doing this? Because if left max is lesser than my R max, okay. So if suppose if we are having only two bars, okay, and uh, one is this and another is this. So what amount of water it can be stored? Suppose this, if this is L max and this is R max, so water, what amount of water is stored will depend on this L max only. Will depend on L max only. Uh, okay. So that's why if our L max is smaller than R max, then it is obvious that on the left, this this is the only the height which is greater, and this is also minimum than R max. Okay, so in that case, this is the only height up till I can store the water. So if L max is lesser than R max, then I will add to my result L max minus height. L max minus height. So yeah, L max minus height. So so which currently L max is 0. So L max minus height L. L is pointing to this. So L max 0 minus 0. I will add 0 to my result. And also increase my pointer. Also increase my pointer. Now my L will point to this. Now again, and also I will update my, and each time I will update my L max and R max. So after this traversal, my L max and R max will be, let me update it. So L is 0, so L max will remain 0, and R max, R max is 1. R max is 1. So now I will increase my pointer, left pointer. Now again I will check whether L max is lesser than R max. L max is lesser than R max. So again I can see that L max is L max is L max is 0 and R max is 1. So again, it is smaller. Again, what I will do, I will uh, do L max minus height, current height, means height of L. So which is L max is 0 and current current height is 1. So current height is 1. So it is wait. Something I'm missing. So L is 0, R is okay. Okay. So one thing I forgot to tell that uh, we will maximize this L max and R max at the beginning only. So it will be 1. If I'm standing at this, then previously our L max was 0. Now L is 1. So our L max will be 1 and R max is 1. Okay, as you can see this at the beginning I'm doing. Okay, now again I will check whether L max is lesser than R max, lesser than equal to. Yeah, this time equal to. So again I will store this to our result using L max minus height of L. So L max is 1 and height of L is 1. So which is 0 and I will add this to 0. So our resultant will be 0 only. Now I will increase my pointer, left pointer. So it will be moved here. And again, I will, while moving, I will maximize my L max and R max. So L max will remain 1 only as it is 0. So R max, sorry, L max will be 1 and R max will be 1 only as we have, there is no change to that. Now again, I will check whether L max is lesser than or equal to R max. No, this time we can see that wait, sorry. Again it is lesser. So again, what we will do, we will do L max minus height of L. So this time L max is 1 and height of L is, this is L. Height of L is 0. So 1 minus 0, which gives 1, and I will add this to my result. So our result will be 1. Okay, and yeah, so in the next iteration, again, I will move my left pointer. Sorry, I will increase, left pointer will be increased, and in the next iteration, again, I will calculate the L max. So my L is this, and my L max is 1. So greater is this one, which is 2. So my L max will be 2, and R max will remain same. Let me clean it for better understanding. So my L is here and my R is here. Now again I will check. Is my L max lesser than R max, lesser than equal to R max? This time we can see that L max is greater. So this time L max is greater. So we don't know what height is on the right. Whether we have height greater than this. So we are not sure what amount of water we can store. So this time what I will do, I will move my right pointer. Because right is smaller, I know that this much water only be stored. Okay. So this time I will move my right pointer. So this time what I will add to my result, I will add to my result R max minus height of R. Height of R. So R max is 1 and height of R is 1. So which gives to 0. So I will add it to result. There will be no change. And I will move the right pointer. My right pointer will be here. Now again, we will, in the next iteration, I will maximize our Lmax and Rmax. So Lmax will remain same. Rmax will change because this time R is 2. So our Rmax will become 2. And again, I will check whether Lmax is lesser than equal to Rmax. Yeah, both are 2. It is lesser than equal. So this time I will do Lmax minus height of L. So let me clean it. So Lmax is 2 and height of L is 2. So which is 0. So this 0 will be added to our result. No change. So after this, I will move my left pointer. My left pointer will be here. Okay. Now in the next iteration again, I will maximize my Lmax. So our Lmax will remain 2 because this time L is 1. So 2 is maximum and Rmax will remain 2. Now again, I will check Lmax. Is Lmax lesser than equal to Rmax? Lmax Lmax lesser than equal to Rmax. Oh yeah, it is lesser. So again, we will do what we will do. We will do Lmax minus height of L. Lmax is 2, height of L is 1. So this is giving 1. So I will add this 1 to my result. So it will become 2 and increase my L. Now my L is here. Here. Now again in the next iteration, I will maximize my Lmax, Rmax. So this is maximum because L is 0 and R max will remain same. Again, I will check is L max lesser than equal to R max. Yeah, it is lesser. So again, I will do L max minus height of L. So this time L max is 2 and height of L is 0. So 2 minus 0 will give 2 and this 2 will be added to my result, which it will become 4. And I will increase my L. Okay. So for this, we will do again L max is lesser than R max. Again, it will be 2 minus 1, which it will give 1 and it will be added to our result and it will become 5. Okay. So let me clean it. So our result has become 5 and our L will be moved to here. Now this time L max is not, L max is greater than R max. So this time R will move. Sorry, R will not. First we will calculate then move. So this time we will do R max minus height of R minus height of R. So R max is 2 and height of R is 2, which is 0. So we will add this to our result and increase our right pointer. Again, we will maximize this L max and R max. So there will be no, L max will change because L is now 3. So L max will be 3 and R max will remain 2 only. Now again, we will check L max lesser than equal to R max. No. So again, we will do R max minus height of R. So R max is 2 and height of R is 1. So it will give 1. I will add this 1 to my result. And this will become 6. And I will move my pointer to right. So again, we will check whether L max lesser than equal to R max. No, it is not. So we will do R max, which is 2. Yeah, before that we will maximize. So it will remain same 3 and 2. So 2 minus height of R, which is 2, which will give 0. So it will remain same and I will increase my R. So we can see that R and L are on the same place. So we will stop the loop and this is our result. Okay, so intuition behind this question is that, sorry, intuition behind this logic is that ki if I am standing on a bar, then the amount of water stored ever bit depend on the maximum bar on the left, maximum height bar on the left, and maximum bar height on the right, and minimum between these two. That much water we can store above this. So the same thing is being followed in this. We are maintaining a L max, which is keeping track of uh, largest height bar on the right, sorry, left, and R max, largest height bar on the right. And on the basis of which I'm deciding whether, means how much water my current bar could store. And we are taking minimum among the two. Means if L max is lesser, then that much water only we can store. So in that case, we are calculating and moving our left pointer. That we are doing in this logic. So this was the intuition. Let's go to the code. So this is the code. There is L and right, L and R, which is pointing to 0, and the last bar, and L max and R max, and this is storing the result. And I am running the loop till L lesser than right, L lesser than R, and in the beginning of loop, I'm maximizing my L max and R max with max of height L and L max and height of R and R max. And I'm checking whether L max is lesser than equal to R max. If it is lesser, then I'm adding to my result L max minus height of L. Well, this much water only can be stored in the current bar, that is L. And I'm moving my L pointer. And if it is not satisfying the condition, it will go in else and it will do R max minus height of R and decrease our R pointer and will give our result. So let's run this code. Yeah, it's passing all the given test cases. Let's submit the code. Yeah, it has passed all the test cases successfully. So let's discuss the time complexity of this case in this code. So time complexity for this will be of n, because we are running a loop, means only we are iterating. We are using two pointer and iterating over the array. We are running only one while loop, that is running n times, which is the size of this height arrow. Okay, and space complexity will be of 1. Yeah, so that's all about this question. So thank you for watching. Do like and subscribe.